Hello everyone, welcome to my channel Coding Together. My name is Vikas Oja. Today we will see another Leetcode problem, that is top k frequent elements. It's a medium level question and it's also a very popular question. So let's read the problem statement. That given an array nums and an integer k, we have to return the k most frequent elements, and we can return the answer in any order. So let's see an example to better understand the question. That we have given with a nums array, that is 1 1 1 2 2 3. So as you can see, some elements are repeating, so we have to return the k most frequent elements, where k is 2 here, so we have to return the two most frequent elements. So two most frequent elements are 1 and 2, as 1 is repeated 3 times and 2 is repeated 2 times and 3 is repeated 1 times. So let's see how we can solve this problem. So I've taken the example here. We will be using two data structures. Use two data structures here. First is map and the other is the max heap. So max heap implementation is PriorityQueue we can use in Java. So map is to maintain the frequency of each element. Will maintain the frequency of each element, and max heap will sort the elements according to their frequency. So highest frequency will come first, then the lowest frequency, and then the lowest frequency, right? So in the decreasing order. Simple enough. So let's see. We'll start with iteration of this array, right? So we'll start with each element. So we have our map, so which is an integer. Key is also with where our map, where key is an integer and value is also an integer. So key is the element value, and the value represents the frequency of that key. So we have got 1, right? So 1 is not in the map, so we'll add 1 with the frequency 1. Then again we have got 1, so we'll update to 2. Again we have got 3. Again we have got 1, right? So we will update the frequency to 3. Now we have got 2, so 2 is not present in the map, so we'll add with 2 as a frequency 1. Now again we got 2 in the next element, so we'll update the frequency to 2. Now we have got, now there is 3, so 3 will be added with the frequency as 1, right? Now we have these keys 1 2 3 with the frequency 3 2 1. Now so we have our keys and values ready with the frequencies. Now we will add all the keys in the map, in the max heap, and max heap will sort the keys according to the frequency. So highest frequency will come first. Max heap is a binary tree, actually complete binary tree. So at each level the value is greater than the lower child descendant levels, right? So if level 0 value is greater than the level 1 values, right, or the children values, and level 1 value will be greater than the level 2 values, right? So that's why it's a heap. The maximum will be at the root node, then the values that are smaller than the root node will come at the level 1, and the values smaller than the level 1 will go in the level 2, in this way. So PriorityQueue, that there is an implementation that has in this way. So we'll use the priority max heap implementation in Java, that is PriorityQueue. Now we will add in the PriorityQueue all the keys, and so PriorityQueue takes a comparator The priority queue takes a comparator. Right? So we'll pass in the comparator that will sort the keys according to the frequencies. So comparator will take the frequencies of each element, and finally it will result 1, 2 as the elements present in the queue, the top frequent elements. So let's see how the max heap will be created for this example. So we have all the keys in the map with their frequency. So when we will add all the keys into the heap, so the max heap will look like this. So we know that 1 has the highest frequency as 3, 2 has the second highest frequency as 2, and 3 has highest frequency of 1. So the key at the top level, the root level, is 1, as a root element is 1, so it will be at level 0 with the frequency of 3, and the other two elements, that is 2 and 3, will be the child of 1, like at level 1. So it has maintained a max heap with the maximum element at the top. So let's see the code part of it. We'll start with the function top k frequent with nums and k as an input. We'll define our data structure map to maintain the frequency of each element. Then we'll have a resultant array where we will store the value of each key, the most k frequent elements, so it will be of size k. Right, for each element we'll add a new entry in the map, or if the element is already present, we'll increase the frequency. So this for loop maintains the frequency of each character, each element. Now we'll define our priority queue and we'll pass our comparator with each value a comma b, where a comma b represents the key. So what we are doing is we are doing map.getB minus map.getA. So it will sort the keys according to the frequency of that keys. So the key that has the highest frequency will go at a level higher than the value which has a smaller frequency. So at level 0, the key that has the highest frequency will come, and at the lower levels the elements with the lower frequencies, so they're in a decreasing nature. We'll add in the queue all the keys of the map, where keys represent the elements, and what we will do, we'll initialize a j pointer, and while j is less than k, right, so we'll start extracting, we'll start pulling the elements from the queue till j is less than k, because we need only the top k elements, and we'll start putting it into the resultant array, and we'll increment j++, and while j is greater than or equal to k, we'll stop this loop and we'll return our resultant array. So let's try to run this solution. So yeah, all the test cases are accepted, so it's working fine. Now let's talk about the time complexity of this solution. So as you can see, we are using this for loop to put an element in the put or add an element in the map, so that will be order of 1 for each element. So we have n elements, so it will be order of n time complexity for maintaining the frequency. So the next is priority queue that we are maintaining, right? So priority queue, we are adding all the keys in of the map inside the priority queue, so that will take almost order of n log n, right? Because add all function for adding each element in the priority queue, it's a log n time complexity for pushing and polling, right? So it will be n log n to add all the elements, and finally this while loop is running k times, so it will be order of k log k, right? So now it will be k log n. So adding all the time complexities will be on plus order of n log n plus order of k log n will be approximately order of n log n log n. So thanks for watching this video. I hope you like this video. If you like this video, please share and subscribe. Thanks for watching. Bye.